This is Geometry, Chapter 5, Lesson 4 on page 200. This lesson is on the triangle inequality theorem. Now, we've talked about some equalities with triangles. Or some relationship, actually, between angles. We've talked a lot about angles and triangles, haven't we? Mm-hmm. But a relationship between the angles and the lengths of the sides. Right? Such that if the smallest angle is going to be opposite the what? Smallest angle is going to be opposite the loop. Yes, smallest side. Exactly. The smallest angle is going to be opposite the shortest side. The largest angle is going to be opposite the longest side, right? And we talked about if angle C is greater than angle B, then what can we say about the sides opposite them? Sam?
Side AB is greater than side AC.
Well, let's just call it side lowercase c, right?
Side lowercase c is greater than side lowercase b.
And why can we say that?
Because the opposite sides of unequal angles are unequal in the same order.
Exactly. When angles are unequal, the sides opposite them are unequal in the same order. And also, if sides are unequal, then the angles opposite them are unequal in the same order. Do you remember that? And we learned about external angles, and we know about vertical angles, and we know the sum of the angles of a triangle is 180 degrees. What's the sum of the angles? Okay, if I have 3 sides, the sum of the angles is 180 degrees. If I have 4 sides, what's the sum of the angles?
360.
360. If I have 5 sides, what's the sum of the interior angles?
450.
Close, Julia. 540. How'd you get from here 4 to 5?
I added 180.
180. You're just adding 180 each time. Got it? Now, there's another inequality theorem about the sides of a triangle. And that's what this lesson is about. It has to do with sides. And here's the theorem. It says the sum of any 2 sides of a triangle is greater than the third side. In order for every endpoint to meet another endpoint, the sum of 2 sides of a triangle have to be greater than the third. Okay, let's suppose we have this triangle, which is not really a triangle. It probably ends here. The only way that we can have a triangle where every endpoint meets the other endpoint is if the sum of 2 sides is greater than the third. But in this case, it is not. Does that make sense? So, given any triangle, we can ask, maybe given 2 sides of any triangle, we can ask, what would be the measure of the third side? What would be the range of the measures of the third side? So, let's think about this. If we have 8 and 3, and then maybe we don't know what the measure of that side is. We can figure out the range of measures for the side, because the sum of any two sides has to be greater than the third. Yes.
So they can't be equal to the third?
No. Correct. Unless it's an equilateral, right? Nope, it still doesn't equal it, does it? Because if it's 6, 6, and 6, the sum of 2 is still greater than. No, it cannot be equal to. It will not make a triangle. Every endpoint will not meet another endpoint. All right, so let's just write this equation for these sides and see what our possibilities for the lengths of x would be. All right, so the lengths of any two sides, 3 plus 8, has to be greater than 12, than x. I was adding them very poorly in my brain. Also, 3 plus x has to be greater than 8. And 8 plus x has to be greater than 3. You have to write all 3 equations. Does that make sense? I picked 3 and 8 is greater than the third side. Then I put 3 with x is greater than 8. Then I put 8 with x has to be greater than 3. All 3 of those statements have to be true. And we can come up with a range of values for side, the unknown side. All right, well, we already know this. 11 has to be greater than x. Or said a different way, x has to be less than 11. Can you read it backwards? X has to be less than 11. All right. Now, how do I solve this inequality? Do you remember from algebra how to solve this inequality? Yeah, look, what do I do?
Subtract from both sides.
Yes! I'm going to subtract the 3 from both sides. So now x has to be greater than 5. So x has to be less than 11, and x has to be greater than 5. All right, what happens here? What happens when I subtract 8 from both sides?
It becomes negative 5.
It becomes negative. Do we ever have a negative for a side of a triangle? No. All right, so there's always going to be one equation that doesn't make sense, one inequality that doesn't make sense. So here's the range of values for that third side. X has to be greater than 5, but less than 11. So what are the possible values for X? 6?
7, 8, 9, 10.
That's correct. I could write this as a single inequality. Right? Okay, what if I gave you 3 sides and said, okay, is this possible? Does the lengths of these sides make for a triangle? What about if I just tell you it's 4, 8, and 10? Those are the lengths of 3 sides. Then what 3 inequalities am I going to write? Somebody give me 1. Evangeline, what's 1?
4 plus 8 is greater than 10.
Is that true?
Yes.
That works, okay? What's the second one, somebody? Allie?
8 plus 10 is greater than 4.
Is that true?
No. So,
Is 8 plus 10 greater than 4?
oh, yes.
Yes. Okay, what's the last one?
4 plus 10 is greater than
Is that true?
8. Mm-hmm.
So actually these 3 sides could in fact be sides of a triangle. What if I told you the sides were 7, 9, and 18? Julia, what would be one inequality that I would write?
7 plus 9 is greater than 18.
Does that work? No, because that's 16. So 7, 9, and 18 cannot be the lengths of the sides of a triangle. It would not make a triangle. What if I gave you 5, 5, and 10? Would that one work?
No.
No, because 5 plus 5 is not greater than 10. In order for it to work, the 10 would have to be at least, well, it could be really 10.1, couldn't it? No, it'd have to be less than 10, actually. 5 plus 5 has to be greater than. So it could be actually be 9.9. Have to be something smaller than 10 for that to work. Okay, so what if I gave you X, 9, and 18? Could we figure out what the range of values for X should be? Kamaya, what would be one inequality I would write?
9 plus 18 is greater than X.
And so that would be what? 27
Yeah.
is greater than X. That's simplified. All right, what would be another inequality, Luke?
9 plus X equals 18.
Greater than 18. Yes. We would subtract 9 from both sides. So X greater than 9. What would be the last inequality, Charlotte?
You would do 18 plus X is greater than 9.
All right, what happens when I subtract 18 from both sides?
You get negative.
This is the one we're not looking at, right? All right, so what is the inequality? X has to be less than 27 and greater than 9. It can be written as one inequality. All right, now I'm going to give you guys one to work on your own. What if I have 15, 15, and X? And then we'll do another one. 10, 12, and X.
So we have to find the range.
Find the range, yes. Callie, were you able to get this first one?
I think so.
What'd you get?
I wasn't. This one was a little bit harder.
Uh-huh.
I think I got like 30 greater than X.
Correct. 30 greater than X, and one more.
I didn't get another one.
Okay, look, we wrote 15 plus 15 greater than X. Then the only other one we could write is 15 plus X greater than 15. What happens when I subtract 15 from both sides, Luke?
0,
So X greater than
0.
0. So X is somewhere between 0 and 30. So 1 to 29. Or 0.001, some value, you know, any value like 1/1,000,000th is greater than 0, right? And 29.99999 is less than 30. Luke, did you get this one? What is it?
Got 10 plus X, or X plus 10,
Yeah?
is greater than 12.
All right. So what did that simplify to be?
X is greater than 2.
Correct. Okay, and the other one?
10 plus 12 equals X. And X is less than 22.
That is correct. So X is between 2 and 22.